Hello everyone, my name is iCarly and today I'm going to be teaching you how to factor a quadratic equation using decomposition. So first I'm going to show you a very fast decomposition, just so you can see what it looks like. Then I'm going to explain everything I'm doing. Then I'm going to give you some tips and tricks that you can use in the future. Alright, so the quadratic that we're going to be factoring today as an example is 3x squared plus 4x minus 4. Now, first, I'm going to multiply these two terms together. That'll be negative 12. And then I'm going to factor this out. So 1, 2, 3, 4, 6, and 12. Then I'm going to realize that it's negative. So what addition between one of these numbers is 1 negative, 1 positive can make this number, the b term, and that will be 6 negative 2. Okay, so I'm going to rewrite it, 3x squared plus 6x minus 2x minus 4. I'm going to split these terms apart into two different things, factor them so we can take out the 3x from these two. That'll be x plus 2. And then you can factor out negative 2 from this one. So negative 2x plus 2. You realize that these two terms are the same, so you can split it apart into 3x minus 2 multiplied by x plus 2. This would all be equal to 0. Now, because it's equal to 0, you can split these apart into two cases where 3x minus 2 is equal to 0 and x plus 2 is equal to 0. And then you just solve each of these individually. So this would be 3x is equal to 2, x is equal to 2 over 3. And then this one would just be x is equal to negative 2. All right, that was a very fast decomposition. Let's just explain what exactly I did there to get the answers x is equal to negative 2 and 2 over 3. Okay, so rewrite this down here. 3x squared plus 4x minus 4 is equal to 0. So the first thing you want to do is you want to realize what is your a term, what's your b term, and what's your c term. So the standard way that you'd write this is ax squared plus bx plus c. So you just take down these and see a is equal to 3, b is equal to 4, and c is equal to negative 4. Now what you need to do is find two numbers that will satisfy two conditions. The first condition, and the one that you should start with, is you just multiply the a term by the c term. This would be 3 times negative 4, and this makes negative 12. Now what we need to do is we need to find two numbers that when you multiply them together, it will equal negative 12. So essentially two factors of negative 12 that, importantly, when you add them together, will equal the b term, which in this case is 4. So let's factor out negative 12. So we can realize from the negative sign here that one of the factors, say n1, is going to be positive and n2 is going to be negative, right? Because it's derived from multiplying n1 and n2, if both n1 and n2 were positive, then 12 would be positive, but it's not. Same would be the case if n1 and n2 were negative. 12 would also be positive because a negative times a negative is a positive. So we know that one of these numbers is positive, one of these numbers is negative. So now when we factor negative 12, we get 1 times 12 is 12, then 2 times 6, then 3 times 4. So these are the factors. So we get these pairs. 1 times 12, 2 times 6, and 3 times 4. Now, taking into account that one of these is going to be negative and one of these is going to be positive, we can kind of just look at these and try to add them together with one of them negative and try to equal the b term, which is 4. So we're trying to get 4. And this is kind of a little Sudoku puzzle. We can check 1 minus 12 is equal to negative 11, so it's not that. 2 minus 6 is going to be negative 4, so that's not it because it's negative. But when we see here, this is negative, this is positive, so we're kind of on the right track here. If we flip this around into 6 minus 2, that equals 4. So we found the two numbers. These two numbers are 6 and negative 2. Now what are we going to do with 6 and negative 2? We are going to realize something about equal signs, okay? So this is the equation here. 6 minus 2 is equal to 4. With all equal signs, if you ever find what's on one side of the equal sign somewhere else, so 3 times 4 is equal to 12, right? This is the correct, right? This equation is correct. But because 6 negative 2 is equal to 4, you can just substitute 6 minus 2 into wherever 4 is, and it would be correct. It would be the same thing, because 6 minus 2 is the exact same thing as saying 4. So, taking this information over here, we know that 4 here is the exact same as 6 minus 2, or in this case, because there's this x here, 6x minus 2x. So let's rewrite that. 3x squared plus 6x minus 2x minus 4. So why have we split these up? Splitting these up is incredibly important because now what we can do is we can just put a wall in between these two sides. Put a wall in between these two sides. And think about these independently. So let's go to 3x squared plus 6x first. What we can do is we can factor. Now, both of them have an x in them, and both of them are divisible by 3, so you can just factor out a 3x from both of these. And 3x squared divided by 3x is equal to x, because, you know, the 3 gets canceled out and one of the x's gets canceled out. And 6x divided by 3x is just equal to 2. Now, let's do the exact same thing with the other side. So we know that negative 2 is divisible by negative 2, and also is negative 4. So we can divide that by negative 2. Then negative 2x divided by negative 2 is just x. And then negative 4 divided by 2 is 2. Now what we realize here is that this here and this here is the exact same number. And when it's that exact same number, when both of these things are multiplied by the exact same number, you can rearrange it in a special way. What you can do is you can take these coefficients and just stick them in their own bracket and then multiply it by whatever these numbers are. So that would become 3x minus 2 and x plus 2. Now I'm going to be honest. I'm sure I could probably figure it out if I thought about it a lot. But this whole thing here with, moving this 3x minus 2 to rearrange into this whole thing, it's kind of just something that it's better to just memorize instead of understanding intuitively, at least in most cases. I implore you, if you want to understand it, then go ahead. But if you want to be efficient and effective here, just right off the bat, don't try to understand it. Just understand that something formed like this can turn into this. Now, if we remember up here, this is all equal to 0. Very easy to forget that. This 0 is incredibly important now. This 0 is incredibly important now because 0 has a very, very unique property. If you see there's a multiplication statement here, right? It's written by I have this written in bracket form, but there is a multiplication there. The only way to get 0 out of a multiplication statement is if one of these two terms is also 0, right? One of these two terms has to be 0 in order for the whole equation to equal 0. There's just no other way. So how do we use this here? We know from this property that if a times b is equal to 0, one of a or b has to be 0. We can take two cases here. We can take the case where 3x minus 2 is equal to 0, and we can take the case where x plus 2 is equal to 0. And then this becomes very familiar algebra. This has turned, the second degree question into just two first degree questions. Much simpler. What you can do is you can just rearrange into, put the 2 onto the other side, flip the sign, and then x is equal to 2 divided by 3. Same with here, x is equal to negative 2, just flip the sign, and then you get two answers. X is equal to negative 2 and 2 over 3. Now we've gotten here, gotten the exact same answer, the fast way and the long way. Now let's just explore a little bit into why a few things are happening here. So the first thing that we can understand is, or the first question that I would ask here if I didn't know what was going on, is why the hell are we getting two answers? We have one question, right? How the hell does 3x squared plus 4x minus 4 equals 0? How does this one question get two answers? And that has to do with the degree here. If you don't know, degree is just whatever the highest exponent is in the question. So you look here, yes, it's a second degree question. If you take a normal x squared, y equals x squared, it is a parabola, right? That's what that kind of looks like. Now, if you move this down into a minus 1, it becomes that. And essentially, when we're solving an equation by is equal to 0, essentially what we're doing is just pointing out which points interact with this central line on the horizontal axis. Which lines intersect with y is equal to 0. And that's why here, in the original term where where just y is equal to x squared, you only have one answer because that one answer is 0. But in most situations, and in this situation in particular, you'd have two different answers for whichever arm of the parabola you're on. And of course, there are other parabolas where you have it like right here, and you can see there's no place that equals 0, and that's where you get an equation that has no solution, which if you ever get this, that would be equals 0. So how do we realize that something has no solution algebraically? I will answer that in the next video when I go into the quadratic formula. But for now, let's just go back to analyzing the rest of this method. All right, so another question that you might be asking is, we know why 4 is equal to 6 minus 2, but why the hell does 4x become 6x minus 2x? Now, hopefully just looking at it over here, because that's what we did over here, hopefully looking at it is a little bit obvious, but if it's not, that's okay. I'm just going to explain why. So, if we take any two numbers, right, so a plus b, and then make that equal to c. So whatever we do to one side of the equation, right, happens to the other side of the equation. That's kind of the central point of algebra, right? Making sure that whatever happens to one side happens to the other side. So if you multiply one side by 4, that'll be 4a plus 4b equals 4c. Notably, while these two equations are not equal to each other, because you've done something to one, you multiplied 1 by 4, the two sides of the equation are still equal, right? So if instead of a and b, it was 6 plus negative 2, and then c is 4, right? This, instead of writing 4, it's like the inverse. We're writing a variable instead. So 6x minus 2x equals 4x. All right, so I've started a new document here, just so I can have more space, because the first one is kind of running out of space. And I'm just going to show you a neat little trick with some easier quadratics to solve. Because if you realize this last one, it has an a term, a b term, and a c term. It's very important to be able to do those, but a lot of the times you're going to see quadratics that look like this, where a, remember the thing is ax squared plus bx plus c equals 0. A lot of the time you're going to see quadratics where a isn't there, right? Sorry, I don't want to dot thing. A is not there. What that means is not that a is equal to 0. A is not equal to 0. A is in fact equal to 1. And of course you can see here, this is the b term. B is equal to negative 1 because there's a negative sign there. When you have a quadratic like this, decomposition gets a lot easier. And let's see why. So I'll do this the long way, and then I'll show you how you can cut out like half of the steps or more. So you'd find the factors of 6, of negative 6. So that's 1, 2, 3, and 6, right? And you'd realize that 2 minus 3 is equal to negative 1. So we have our two numbers, 2, and negative 3. So we have x squared, just substituting these numbers into the negative x, is plus 2x minus 3x minus 6 equals 0. We can do our same little thing, cutting it in half, taking out an x into x plus 2, and then we can take out a negative 3 over here, and then x plus 2. Realize that these two are the same number. You can rearrange it into x minus 3 and x plus 2. I'm just going to put a star here just for later, because this step is where we're going to come back to, but we're going to finish this. X minus 3 is equal to 0. X is equal to 3. X plus 2 is equal to 0. X is equal to negative 2. So why did I put a star here is the question. It's because if you realize these two numbers are very familiar. They are the exact same as these two numbers. And that is a special property of quadratics that have a is equal to 1. So if you have any quadratic where a is equal to 1, right? These special numbers are the same ones that go into the factor here. So you can just straight up go from x squared minus x minus 6. You can realize the two numbers are 2 and negative 3. And then you can just go straight to x minus 3, x plus 2 equals 0. See, I'm always messing this 0 up. The 0 is very important, though, because if it wasn't 0, you'd have to do a lot of other stuff. So now you can see, just that's a little cheat sheet. You can skip all of this stuff if you want. Do keep in mind that if there is an a value that is not equal to 1, you're going to need to put in a little bit of extra work, and you're going to need to actually know how to do it the correct way. All right, if you have any questions, please leave it down in the comments below. I would gladly answer any questions about quadratics, specifically this method, if you would like. And as stated before, I'm probably going to go and do another lesson about the quadratic formula, and then also completing the square. So hopefully this will be a 3-part series. All right, thank you for listening, and thank you for watching. Have a great day.